Hey everyone, welcome back to the series Mastering Docker 2025 from developer to production. In the last video, we looked at Docker's architecture and how its components, the client, the daemon, images, containers, and registries work together. In this video, we are going to zoom in and explore container architecture, what it looks like, how it compares to virtual machines, and why containers are considered such a game changer in the modern development and DevOps. By the end of this lesson, you'll clearly understand the difference between the virtual machines and containers, the trade-offs of each, and why companies are moving more and more towards containers. Alright, let's jump right in. In the introduction video, I told that Docker is nothing but a virtualization software. But in this video, we'll see how Docker containers are different from virtual machines. What are the key differences that make Docker containers one of the best choice for modern companies to go with. In this part of the course, I want to cover two main topics. I'll start by stepping through container architecture and then I'll cover some of the high-level benefits of containers. At this level, you can think of containers and Dockers as roughly the same thing. A Docker container is a type of container. The difference doesn't matter until we go much deeper into the tech. Now, before we move on, if you haven't watched my previous video on Docker architecture, then go ahead and do that now before continuing with this video. Now, as a reminder, with our virtual machine architecture, we have a physical hardware commonly known as a VM host. On top of that, either the hypervisor is running directly or a host OS, and then the hypervisor. This is the difference between, say, a virtual box which runs on an operating system versus VMware, which directly runs on the host. Then we have virtual machines, each of which runs its own guest operating system. This could be the same operating system, for example Debian, or they could each be different guest operating systems. And then running inside these guest operating systems, we have our applications as well as any other libraries or runtime environments. Now, you will recall from the video where I mentioned that running multiple guest operating systems is actually very costly in terms of resources. And this can actually really cause large-scale duplication if many copies of the same operating system are used. It also means because each virtual machine needs to start up its own operating system, there's also added overhead in terms of startup and restarts, although this is less than a physical service. Now, let's compare this to containers. We start with the same hardware. We'll refer to this as a Docker host or a container host. And on top of this, we have our host operating system. On top of this is a container engine. In this case of Docker, this is called Docker engine. Now, so far, this might look familiar, but there are few key differences. First, the Docker or container engine, by comparison, is generally lighter than a hypervisor because it has less to do. Secondly, any containers running on the Docker host, they share the same host operating system. They run as a process in that operating system. It means that containers don't need to run their own individual operating systems. They only need to run the libraries and runtime environment and the application itself. Because of this, containers are much smaller and more lightweight versus the same application running within the virtual machine. It means that on a given piece of physical hardware, running containers versus virtual machines results in more free capacity. It means you can run a smaller host or use the same host but pack in more containers, resulting in better utilization and thus more value for a business. Now, from a high-level perspective, that's the main difference between how you can run a virtual machines and containers. Let's finish up by stepping through some of the main summary points that you'll need to understand. First, containers run on a container host. This is the physical hardware and they run via a container engine. In the case of Docker, this is called Docker engine. Now, a container only contains an application, its libraries, and any runtime environments required. They don't contain any operating system because they share the operating system running on the container host. Each container runs as a process within the host operating system. Now, this means containers are super lightweight and can be densely packed onto a host or started or restarted quickly. Nothing to start or restart an entire operating system for each container is a substantial amount of overhead which is removed. Containers can be impacted by other containers. This is the downside of sharing the container host operating system. It's just a process within an operating system. While the container host OS might have ways to control the amount of resource allocation for a process gets, it's never going to be as tightly controlled and isolated as virtual machines. If one container is noisy, that is, consuming a massive amount of CPU or memory, other containers can be impacted. Just imagine somebody playing a loud music at 2 a.m. in a neighboring apartment. If you live close to this apartment, you will be able to hear this music. And this is the same with containers because they are not strongly isolated from other containers. Any containers aggressively using resources on a container host can impact other containers. Now, there are some ways on modern container engines that this is minimized, but it's something that you should keep in mind. The best explanation I have heard to understand containers is this. They were created to fix an application shipping problem where an application was developed on a developer's machine but didn't work when deployed into production. This led to the famous line that it works on my computer. And well, containers are a way to ship that very computer. Containers are designed to hold an application as well as everything that an application needs to function. This means specific, tested, known working versions of libraries. Once you know the container works, you know it works anywhere that container runs. Okay, that's everything I wanted to cover right now. In the coming video, we'll see what is the architecture of a container and an image. Then we'll go into setting up the software where we can run the Docker containers. And then we'll proceed with our hands-on part. So thank you.